Welcome back to our second part video on related rates. At this point, hopefully you've had a pretty good understanding of how to approach these problems and how to solve them. So, a good idea for this video would be to pause this video before each problem, complete each problem on your own, and then come back and check your work with mine. All right, but just a summary of the first video. Here's a process you want to pretty much go by when solving related rate problems. So first of all, how do you know if it is a related rate problem? You're going to see one of these words most likely in the problem, and that's going to tell you that there's going to be two things that are related to each other, as one is increasing, the other is decreasing, or vice versa, or they're both increasing together, or whatever. Okay, so again, your steps that you want to kind of go to after here: make a sketch, write down everything that you know, everything that's given, and what you're trying to find as well. Step 3, write down an equation that relates your variables together. It usually is area, volume, or Pythagorean theorem, or maybe some type of trig ratio. Okay, now we can plug any constant into our equation. We don't plug any variable into your equation until after the derivative is taken. Then we take our derivative, and then we can put the variable quantities in at this time. And then you solve for what's missing, and then you find your answer, and you make sure you label your answer in terms of correct units. So one problem at a time. Remember, for each one, pause the video before looking at it, and then once I show the answers, feel free to pause the video and look at it for as long as you need. Okay? So here's example 6, talking about an oil tanker spill. We're given the radius is increasing at 50 feet per minute. Okay, we want to know how fast is the area and circumference are changing when r is 20. So we'll need this equation for area, this equation for circumference. This is our work for area, which is changing at 2,000 pi square feet per minute. This is our work for circumference, which is changing at 100 pi feet per minute. Again, feel free here to pause this video and take a look at this for as long as you need. Number 7, a falling ladder. So we're given that x is increasing at 2 feet per second. We want to know how quickly the r is falling. Again, you could have used completely different variables for these, by the way. These are just variables that I chose. Okay, you maybe use y instead of r. So our equation is Pythagorean theorem. Differentiate, plug in everything that we know at that time, solve for dr dt, and our answer is that it's falling at a rate of 7/12 feet per second. You can pause the video here before you try example 8. So here's example 8. The first one, we're talking about if the rocket is rising, how fast is the camera to rocket distance changing? So this is our camera to rocket distance. We want to know if the rocket's rising this fast, how quickly is that distance changing when the y is 4,000? Again, any variable that you chose is fine. You don't have to use these variables. So Pythagorean theorem, derivative, solve. Our answer is 640 feet per second. So this distance is getting bigger, 640 feet every second. And then part B wants to know how fast the angle of elevation is changing. So for that one, we're going to use tangent of theta is equal to opposite over adjacent. Derivative, substitute in everything that we know, and solve. And we get 12 over 125 radians per second. You can pause the video now before trying number 9. So 9 here, we have a pile of sand that's being poured onto this conical shape. The volume is changing at 20 cubic inches per second. We want to know how quickly the height is changing. So the volume of a cone is given by that formula there. To do this here, since we don't know anything about the radius, what we want to do is we want to say, all right, well, I know that the radius is twice the height. So radius is twice the height. And then what I can do here is I can replace r with 2h. And then simplify, and then take your derivative, and then solve. And we get 5 over 4 pi inches per second. Pause the video here before trying number 10. All right, now we have a cone that's draining. Okay, so it's draining at -2 cubic meters per second. We want to know how quickly the height is changing. Okay, we know the height is 16. At this time, it doesn't tell us the radius is always twice the height or anything like that, but it does tell us the tank is 16 meters high and its top radius is 4. So we know that the radius will always be 1/4 of the height. The radius will be 1/4 of the height. So I can replace radius with height over 4. Simplify, take your derivative, put the numbers in, and solve. So you get -2 over 9 pi meters per second. And one last time, you can pause the video here before trying our last problem of the worksheet. So the first question saying, at what rate is the length of the shadow changing? We know this is changing at 3. It's growing larger by 3 feet per second. We want to know how quickly this is changing. Set up our proportion. 6 is to 10 as x is to d plus x. And then cross multiply, simplify, take your derivative, substitute in and solve, and we get 9/2 feet per second. And then B, at what rate is the tip of the shadow changing? So we want to know this tip here, how quickly that's moving. So we want to know dx dt plus dt dt, how quickly both those two are changing added together. All right, we already know this one is 9/2 and this one is 3. So we add those together and we get 15/2 feet per second. Okay, that is the summary of our practice problems on related rates. Thanks again for tuning in today. Come back tomorrow for some more problems.